Hello everyone, welcome to the digital electronics class. In today's class we will discuss the topic flip-flops. A flip-flop is the most important memory element which is made up of an assembly of logic gates. A flip-flop is a bistable electronic circuit having two stable states, that is, its output is either low or high. The most elementary form of a flip-flop is known as a latch, which is shown in the figure 1. In the figure 1, two NOR gates A and B are used. The output of the NOR gate A and the output of the NOR gate B are both complement of each other, that is Q bar, this is the output of gate A and this is the output of gate B. Both these outputs Q and Q bar are complement of each other. We will see that this latch circuit has two stable states. Suppose that the output state of A is low, then the input to the gate B is also low, which causes the output of the gate B at high level. Now output of the gate B is input to gate A. A high level input to gate A results in a low level output of gate A. This is one of the stable states. Thus we find that this circuit is in a stable state and this is one of the stable states. Now let us consider the other case. Let us now suppose that the output of the gate A is high. Then the high output at gate A is input to gate B. So high output at gate B results in a low level output of gate B. Again, this low level output of gate B is again input to gate A. So low level input at gate A again results in a high level output through gate A. This is the second stable state of the circuit. So from the above discussion we note that the output Q and Q bar are always complementary to each other. This circuit has two stable states. In one of the stable states, the value of Q is high or 1. This state is known as one state or set state, whereas in the other stable state we find that the value of Q is equal to 0. This state is known as the 0 state or the reset state. Also, if the circuit is in the one state, it will continue to remain in that state, and similarly if it is in the 0 state, then the circuit continues to remain in the 0 state. This property of the circuit is referred to as memory, that is, it can store one bit of digital information. That is why we can say that a flip-flop has memory. Now we find that since this information is locked or latched in this circuit, so this circuit is also known as a latch. The figure 2 shows the behavior of a NAND latch circuit, which can also be explained in a similar manner as discussed above for a NOR latch. This is figure 2, which shows a NAND latch circuit, which is similar to that of a NOR latch circuit. In the latch circuit shown in the figure 1 using NOR gates and in the figure 2 using NAND gates, we find that there is no possibility of entering the desired digital information to be stored in it. In fact, when the power is switched on, then the circuit switches to one of the stable states, either Q is equal to 1 or Q is equal to 0, and it is not possible to predict the state. The flip-flops are used in the storage circuits, counter stages, shift registers, and many other computer applications. This is all about flip-flops. In the next class, we will discuss about the various types of flip-flops which are used.